This is the ICS3000 dual pump, which is very similar to the ICS5000, ICS5000 Plus, and the ICS6000. Now these are considered IC pumps, so lower pressure. They go to 5,000 psi, and the HPIC pumps are for higher pressure, and they also go to about 5,000. But the HPICs are designed to work closer to 6,000. But they're very similar. There's a few minor differences in the piston seals, and in my experience, the weak spots in these systems are the actual connectors or ferrules, which are tough to get sealed beyond 4,000. They have modern ferrules that are intended to be higher pressure, but in my experience, they don't work quite as well as they're supposed to, and you have to torque them down quite a bit, and it collapses some of the tubing. Okay. As you can see, we have the upper panel here. We have a power. You can prime and turn on a pump if you're not connected to a computer. We got a primary pump head, secondary pump head. Secondary pump head has the pressure transducer. There's your purge valve. And what happens is we come in here. This is from the Alliant bottles, which I don't have set up at the top right now. But these four go to your Alliant bottles, go through a degasser. These are in parallel, but it's only one degasser motor for both pumps. Okay, but these have independent chambers, so the mobile phase doesn't come in contact with each other. And then over to the gradient valve, and the proportioning or gradient valve here leads into the inlet of the pump. And sometimes you gotta watch these guys because this brown tubing has a tendency to kink. And I can see a kink on that one that I don't like. And if I was installing this in a laboratory, I would definitely be changing that out immediately. We have our piston seal rinse here. This is to rinse the back end of the pistons as they retract out of the piston seals. That's a drying zone in contact with atmosphere. So if you're pumping any sort of salts, hydroxide, methylsulfonic acid, anything like that, you're going to experience salting on the piston. And then when it drives back through the seal, you're going to get scratching and premature damage on that piston seal. Okay, so it's going to come in again through the degasser, through the proportioning valve, into the primary pump head, out of the primary pump head into the secondary pump head, comes out into what we have here. If you get a close up on that, that is actually a gradient mixer. A GM4 is a 2 mil mixer, so this is set up for 2 mil application, which ranges from about 0.1 mil per minute to about 0.5, but generally about 0.25 ml per minute. If you see a GM3 mixer in there, that's for a 4 mil application, and that will be closer to 1 mil a minute, ranging from 0.5 to 2 mil per minute. Okay, you can always add them in series if you need additional, or you can take them right out. A lot of these are isocratic, like we don't have gradients, because you're running with an Alliant generator, and those don't require a gradient mixer at all, but we still like to keep them in there because they also act as a pulse damper. Okay, now this is the exact same system, just stacked on top of the other guy. Then we can come around, I'll show you the service bay. So what we're looking at here is we've got a main board. Okay, up top we got a main, we got a pump relay board, and these can be configured in single pump, dual pump, single pump isocratic, single pump gradient, dual pump isocratic gradient combos, dual isocratic, dual gradient, upper gradient, lower gradient, upper isocratic, lower isocratic, things like this. So they're all decided with these pins here, depending on the configuration of these jumper cape pins. That'll define what the firmware is going to pick up in terms of identification. And the independent pump driver board. Got a few older parts in here because this is a 3000. But now if you compare it to the newer models, it's almost identical. There we have the vacuum degasser module. That's a common failure point. If you run them 24/7, unfortunately there's not a shut-off. If it's programmed correctly, that should be turning off each sample and then turning back on. I do find they get left running even though you're not injecting samples, and then they prematurely die. You can see inside if I turn this around. It's a little dark in there. You can see it. You got your cams. These are grease points here. Cams. And then you got the upper one, so they're exactly the same. Alright, in a nutshell, that's the DP. We're going to go over that again in detail later. And taking it apart, doing full maintenance on it.